Hello, my name is Madison Gitson. Everybody can call me Maddie. Just a little background about myself before I get into my project description. So I just graduated from Penn State University in May with my nuclear engineering degree. During my undergraduate, I had the privilege of working at the research reactor we have on campus, the Penn State Brazil nuclear reactor. There, I did energy calibrations that are needed for NRC regulations, which is the Nuclear Regulatory Commission. So I really enjoyed my work there. And following up with that, I did some research as a Westinghouse Fellow on a neutron multiplicity counter, which is a different type of detector used for fissile material. And during that fellows program, I actually was introduced to the Masters in Engineering Law and Policy program that is just launched by Penn State this year. So I am part of the first cohort of students, and it has been a great experience. It's great to see the bridge of science and policy, and that people are trying to actually do something in that field. So my passion for nuclear policy hopefully will have somewhere to go. So with that, I believe that was a little bit background on me, and I will get into my project description for the EnvironMentors program. So as I said, I am a graduate student in the Masters in Engineering Law and Policy program at Penn State. And I did an undergrad in nuclear engineering. So that is where my main focus is at. And another project that I am involved in is called the PIMA-NA. It stands for the Post-Industrial and Midwest Appalachia Nuclear Alliance, which is trying to transform the Appalachia region, which is also known as the coal country, there are towns that once were booming due to coal production that now have been left vacant. So we are trying to integrate advanced micronuclear reactor technology or small modular reactor technology into those communities to help economic success. So for this project, I thought I would contribute a little bit to that work. And so I want to explore the feasibility of the integration of an advanced micronuclear reactor within the energy sector most polluting systems. So the diagram shown on the screen is there is work currently being done to explore the feasibility of these things. And we currently have light water reactors that are operating. They have been operating since the 1950s, and they have been giving us a clean energy source. So we are trying to expand upon just the energy source of electricity, and we're trying to use the heat that is now being provided. So using the heat and electricity, there are many different avenues that we can go other than just electricity as shown, such as industry or chemical processes, or even hydrogen for electric vehicles, which is now becoming even more popular. So within the group project, I would like researchers within the team to identify the main polluters within their area and establish a baseline limit for emissions. So establishing the baseline limit for emissions, I think, is a really important thing to do because we need to understand how we are affecting these communities. If it is for the better, hopefully it will be for the better. So on the chart to the, I guess it's my right, but I gave a little diagram of the current global emissions, greenhouse gas emissions that we are currently seeing. And as you can see, a lot of it has to do with electricity and heat production. So there has been studies done about integrating advanced micronuclear reactors into operating coal plants, which the NRC has published, and there is feasibility there. So again, this could be an area that is explored. If the main polluter is a coal plant within your area, that could be something that we would be able to explore. But I also don't want to limit that. So there's industry processes that might have capabilities. Transportation might have an option here. The railroad systems, there needs to be hubs for energy. So that's an option as well. And buildings, there is green infrastructure, LEED certifications, there is an option for that alternative, but a lot will have to do with the cost there, which was something that researchers will explore. And the last one would be agriculture and forest things. And so the nuclear science actually does a lot with agriculture. We do sterilization with seeds, and this actually will help give different, what's the word I'm looking for? Different mutations to that seed to allow for different varieties of crops. So that way crops can actually produce during these climate change scenarios. So there's an option there to explore feasibility with micronuclear reactors, but I want it to be something that can benefit your community. And so again, we're going to look at the feasibility of systems integration, and this will be explored based on the technological characteristics and standards. So as I said, there will be electricity, and then there will be heat, and these will go to different things, of course. So depending upon what process you will use, you might have to come back to this diagram to see if we can use hydrogen, or if it's just like electricity, or if it's heat for chemical feedstock or polymers and plastics. So that is something that you will be able to explore within your research. And then the last part that I have a personal interest is the community and stakeholder engagement and feedback utilized to determine a stakeholder assessment. So with implementing new reactor technology, I think it is very important to get the public's feedback. I think that's something that has been missed in the past. So I want you guys to explore all the different avenues that are affected by this energy integration. So I gave this diagram because you can see that there is a lot of people that play a part in the rule of a nuclear power program. And I'm sure there's more that we haven't even put on this program. I can think of one right now, and it's just the education community around that plant. So with my background in nuclear policy, engineering, and law and policy, which I'm trying to do and get my master's in, my side obviously goes to the government and regulatory bodies, which hopefully utilizing your research, I will be able to make government and regulatory recommendations based on the data that you guys have been able to give to me. And I can use my knowledge in the governmental side to see what can be done to change these things. So I'm hoping that's what we can get out of the program. And as working in a team and having good communication, I believe that's something that we can do together. So I hope this presentation was a little interesting to you, and hopefully it gave you some insight to what we will be doing throughout the semester. I look forward to talking to you guys, and thank you for listening. Bye.